Hoje egipsões, é poético. Né? E o egipção, até dois, né?
Eunice,
See you all here. Now, as the more perceptive of you have probably realized by now, this is hell. The devil? Goody. But you can call me Toby, if you like. We try to keep things informal here, as well as infernal.
Ajabelaka.
Hiyo
Tan, laka. Hizi vai mwalimu.
Atamvera, mwumve kachela kalaka. Tamvera. Dice. E
That's good, bro.
everything. Hello everyone, I hope you are all okay. I welcome you to today's session. So as we said last time, we are going to do our first TD. So I'd sent this TD in the group. I hope you pass through it. We are going to apply what we learned in the course. So if you had problems in the course when at the lesson, I'm sure this time all your questions will be answered. Yeah, and then I want to say thank you to those who've been submitting their work, those who've been trying, even if you don't manage to solve, but if you're doing something, at the end of the day, you understand what you're doing. So trying is very important. I hope we've passed through the questions. Yeah, and you have your answers. So the answers which you found, you are going to compare them with what we're going to find today together as we solve this. It's nothing new, it's the same thing. So where you've got questions, you are free to ask. Where you're not clear, you ask. This is a TD, answering questions. So as I always say, I'm not here to motivate, but I'm here to teach. So if you don't understand, you ask. So we'll start with our first question. Start with exercise 1. Exercise 1 says effectuer la division euclidienne d'un A du polynôme. So A is equals to 2x to the power 4 minus 3x to the power 3 plus 4x to the power 2 minus 5x plus 3, which must be divided by x squared minus 3x plus 1. So we've got the second one, the third one, A, B, C. So here is just us using the theorem, the Euclidean, using the divisio Euclidean. There's no finding the PGCD, it's just you applying divisio Euclidean. I expected everyone to get this and everyone to answer it. So on exercise 1, we're just going to answer the first one. And then the rest, you do them on your own because it's the same thing. So I'll just answer one, and then the rest you shall do them. And then if you want verification, when you do them, you can send. You can send. When you do them, send, and then I'll correct you. Yeah, so on question 1, so this is the solution. Series A correction, exercise A. So the first one, so this is this is how we put it in divisio Euclidean. This is how we put it in divisio Euclidean. So we've got x to the power 2 minus 3x plus 1, which is dividing 2x to the power 4 minus 3x to the power 3 plus 4x to the power 2 minus 5x plus 3. So what we're going to do here, we know the degree of this whole polynomial is x squared. The degree of this polynomial is 4x to the power 4, and this coefficient is 2 here. Its coefficient here is 1. So this into this is going to give us 2x to the power 2. It's going to give us 2x to the power 2. 2x to the power 2 times everything here. So this times this is going to give us this. This times this is going to give us this. This times this is going to give us this. Then like terms, we're subtracting like terms. This and this will give us 0. This is negative 3x to the power 3 plus this and this will cancel. So we have plus 6x to the power 3. We're going to have 3x to the power 3. These are the same power, so they can work out. 4x to the power 2 minus 4x to the power 2 is going to give us 2x to the power 2. This minus 0 is going to drop. This minus 0 is going to drop. So we have this. We check again. The degree here, its degree is greater than the degree of this. So this can still go into this. So this into this, you're going to have 3x. 3x times everything on top. 3x times this, you're going to have 3x squared. 3x times negative 3x squared, negative 3x, you're going to have negative 9x squared. 3x times 1, you're going to have 3x. Like terms, again, these, they'll cancel. Like terms, you put them together, these and these. 2x squared plus 9x squared, you're going to have 11x squared. Negative 5x plus minus 3x is going to give us negative 8x. And then in 3 minus 0 is going to be 0, or it's going to be 3. And then we see the power here. Can this still go into this? Yes, they are of the same power, so this can go into this. So this into this is going to give us 11. 11 times this to be 11x squared. 11 times this to be negative 33x. 11 times this to be 11. This and this will cancel. Negative 8x plus 33x to be 25x. 3 minus 11 to be negative 8, which is equals to our remainder, and this is our Q. That's all about divisio Euclidean. It's the same for question B and C. I'm just going to do the same. When you reach at the point where this here cannot go into this, then you can stop your divisio Euclidean. You have solved. You found the Q and the R, and you can put them in the equation. Yeah, so there are some who found this answer. Those who never found this answer, this is how you're supposed to do it. Simple and straightforward. Make sure when you're doing the numbers, the signs, be careful with the signs. That's the main reason I put the minus outside. Then when I'm doing, I make sure I follow it. Yeah, so that you shouldn't confuse yourself. Some of you are making errors because when doing the signs, you mix the signs. So be careful and be calm when you are solving, when you are doing this, because you've got a lot of things to calculate. Yeah, I hope we're clear on exercise 1. Are there any questions?
Okay, I'm a bit lost. Could you repeat how you did it again? Because I got somewhere lost. So I want to see from your explanation again why I got mine wrong.
Okay, no problem. So, as I said, we have x squared minus 3x plus 1. Then we've got 2x4 minus 3x to the power 3 plus 4x squared minus 5x plus 3. So here we're doing divisio Euclidean. I'm saying be careful with the signs. So the power here, the degree of this whole polynomial, we learned about degrees, is 2. The degree of this whole polynomial is 4. The coefficient is related with the degree. So the coefficient of this polynomial is 2. The coefficient dominant. The coefficient dominant of this polynomial, this whole polynomial is what? 1. So x squared into 2x to the power 4 to give us 2x squared. Then you multiply this with this polynomial. This times this to be 2x to the power 4. This times this to be negative 6x to the power 3. This times this to be 2x squared. Like terms, you group them. This minus this to be 0. Negative 3x, the minus here and this, they'll cancel to be plus. So negative 3x plus 6x to the power 3. It's going to give us what? 3x to the power 3. 4x to the power 2 minus, this minus will be distributed here, minus 2x squared. It's going to be 2x squared. Negative 5x minus 0 to be negative 5x. 3 minus 0 to be 3. We check again, this is another polynomial. This is the remainder. After you did this into this is your remainder which you find. It's not always, the remainder is not what, it's not only what you write here. Why we write this? Because this is the notable one. This is the last one. So we get this as our remainder, but when you subtract, we consider this to be our remainder. That's where most of you, when you are finding the PGCD, you are getting just the one which you've named. That's why some of you are making mistakes with the PGCD. It's not only those that we name if we can't divide it, the remainder find is that's the only remainder. No, this is a remainder here. This is a remainder when you subtract it. When you subtract the 2, this is the remainder here. And when we subtracted the 2 again, this is the remainder. And we get this now. So you guys, when doing the PGCD, you are making a mistake of getting only the one which we named. Our rule says get your PGCD always, it's your remainder which you found before you found your remainder to be 0. So if here you had 0, you'd have gotten this to be your remainder. This would have been your remainder. I just wanted to note that. So here we have this. Then we check, can the degree of this is 2, the degree of this is 3. So this can still go into this. So this into this, it will be 3x. 3x times this to be 3x squared. 3x times this to be negative 9x squared. 3x times this, it will be 3x. Like them together, this and this will be 0. This 2x squared plus 9x squared to be 11x squared. Negative 5x minus negative 3x, it will be negative 8x. 3 minus 0 to be 3. We check again, it's the same. This can still go into this. This into this, it will be 11. 11 times this, it will be 11x squared. 11 times this, it will be negative 33x. 11 times this, it will be 11. Subtraction, this and this will cancel. Negative 8x plus this will be distributed here to be plus. Plus 33x, it will be 25x. 3 minus 11 to be negative 8. This is our remainder. This is our quotient. Our quotient in English. This is our quotient. This is our remainder of the division Euclidean. The one who asked and those who are had some challenges. Is it clear?
Yes. Clear.
Yes.
Okay, so if we're all together, we can raise our hands and then you solve A, B, and C. You try them out. It's the same thing. Okay, that's good.
Wait, I have a question.
Yes, yes.
Are you saying for PGCD is while we divide the remainders until we find 0 or
Yeah. For
Okay.
PGCD, you only stop when you find your remainder to be 0. But for division Euclidean, when this cannot go into your remainder, then you are going to stop. That's why we in our notes we said we're only going to stop when the degree of a remainder is less than the degree of what will be dividing the remainder. That's when we stop. Yeah. So the same calculations for the other questions. We go to exercise 2. We go to exercise 2. So exercise 2 says determiner un PGCD de deux polynômes de A égale x squared minus 1 et B égale x puissance 3 moins 3x moins 1. So we're going to do these two, and we know that here the degree is greater than the degree here. So this will be dividing this. So we go to our Nankan, we're finding the PGCD. So we've got A is equals to this and B is equals to this. This is our A, this is our B. So this is the PGCD one now. We say x squared into this, it will give us x. X times this to be x to the power 3. X times negative 1 to be negative x. Like terms together, this they'll cancel. This is negative 3x. This will be distributed to be plus. So negative 3x plus x to be negative x. Negative 1 minus 0, it will be negative 1. So this is our, we'll name this to be remainder 1 because this cannot go into this. So if they told you to find to use just the division Euclidean of these two, you would have stopped here. This would have been your final remainder, and this would have been your Q. You would have stopped here. But we're looking for the PGCD. So if this cannot go into this, but this can go into this, then we're going to draw a line where we divide this into what? Into A. So we're going to say x squared minus 1 is equals to A. Negative x minus 1 is equals to R1. Then we do negative x into x squared to be negative 1 over 2x. Negative 1 over 2x times this, it will be x squared. Negative 1 over 2x minus 1, it will be what? It will be positive 1 over 2x. We do subtraction, this minus this to be negative 1 over 2x. This does not like term, so to be negative 1 minus 0. Negative 1 minus 0 to just come and drop. This here to be 0, right? Negative 1 minus 0 to be 0. The negative you distribute it here to just, this will just drop with a negative, so to be negative 1 over x minus 1. Can this still go into this? Yes. So negative 2x divide negative 1 over 2x is going to give us what? Positive 1 over 4. Positive 1 over 4 times this is going to give us negative 1 over 2x. Positive 1 over 4 times negative 1 is going to give us negative 1 over 4. Subtraction, this minus this, it will be what? 0. This plus this, it will be what? Negative 3 over 4, which is our remainder, is equals to 2. What are we going to do here? We're not finding 0. I have a question. Since our non-can, we said we shall only stop when our remainder is equals to 0. Anyone to help us? What are we going to do here? We're all solving this question. A TD is we are all supposed, because we all learned this, so we're all supposed to help one another to solve this. Jabess has even asked a question. Why is the remainder not equals to 0? Someone to answer us? There are some of you who, okay, there are some of you who solved it. You just reached up to here. You ended up to here, most of you. So the two conditions are these. It's either you find a constant or you find 0. 0. So the thing is a constant. 0 is a constant. That's why we never got 0. When we found that our remainder is equals to 0, we don't get 0. We get the remainder before you found 0. But if you find a constant, you get the constant, but you make the constant unitaire. That's a very important. The unitaire, a PGCD is always unitaire. So here we found a constant, and our PGCD is just our PGCD, we're just going to get this same, and we make it unitary. And for us to make it unitary, we multiply it by negative 4 over 3. That's donc PGCD AB égale 1. So if you are going, your main aim is you finding your remainder to be equals to 0. But if you, in a chance you find that your remainder is equals to a constant, then you make your constant unitary. So always when you find it's a constant, your PGCD will be 1. If you find a constant, your PGCD is 1. That's what you are supposed to know. If you find that it's a constant, which you find your last remainder gives you a constant, just know that your PGCD is equals to 1. Are we okay?
Sorry, I missed you. You said you multiply negative 3 over 4 by what?
How can you make negative 3 over 4 to be unitaire? The one who asked
you multiply it by the inverse.
The inverse of it, right?
Yes.
So I multiplied with negative 4 over 3. I multiplied it with negative 4 over 3, and it gave us 1. Because in my head, I know that PGCD must be unitary. So if you find it's a polynomial, what do? If it's not unitary, you make it unitary. If it's a constant, just know that your PGCD is equals to 1. So for you to make it 1, you need to multiply with the inverse of it. That's all. Are we okay? Are we okay? Jabez. Lawrence.
Yes,
Are we okay?
we're okay.
Yeah, well,
Okay. Any other questions on the PGCD? Have you understood on the PGCD?
Okay, could you repeat just starting from where you found the arrow and going down?
Jabez, where is Jabez? Is Jabez? Jabez is here. Can you help us to explain? Jabez, is Jabez there?
Yes, I mean,
Yeah, can you help us to explain to your friend, since you've said yes, you've understood?
okay.
Yeah.
So start from where it says negative 2x minus 1 equal to r. So as you can see the equation for b there, b is equal to negative 3, oh, b is equal to x to the power 3 minus 3x minus 1. So that power, the degree of that equation is x to the power 3. So meaning that x to the power 3 can't enter into negative 2x, since x at the power of 1. So what we're going to do is we'll get this remainder, negative 2x minus 1. Yeah, negative 2x minus 1. So take it this side, and I've used in y is x squared minus 2. Okay, here it's x to the power 2, which can't enter into negative 2x. So what we're going to do is we'll take this same equation, we'll bring here this equation a. So it will be x squared minus 1 is equal to 2. Then the remainder here, we'll take it to this side. So what we're going to do here is, since this power, this has power of 2 and this one power of 1. So meaning that this one can enter into x of the one which has power of 2. So what we're going to do is x to the power 2 divided by negative 2x. So the answer here will be negative 1 x over 2. So this is the answer. So what we're going to do is multiply this same answer by that same equation, the remainder. So what we're going to do here is negative 1x over 2 times negative 2x. So the answer here will be x squared. Then negative 1x over 2 multiply it by negative 1. The answer will be positive, since negative times negative will give us positive. So the answer will be positive 1 over negative 1 over 2x. So we have x squared minus x squared. So that one will give us 0. So according to the law of polynomials, the powers has to be decreasing. So here we have, in actual sense, it was supposed to be x squared plus 0x plus minus 1. So since it's 0, so we don't have to write it. So what we're going to do is just multiply and subtract direct. So we have x squared minus x squared, that is 0, so won't cancel. Then the following power, we have x 0x, we have 0x. So what we're going to do is 0x squared, or 0x minus 0. So I mean 0x minus plus 1x over 2. So we have 0 minus 1 over 2x. So the answer is, we just multiply negative times positive here. So the answer will be negative 1x over 2. Then here we have constant negative 1. And here we have 0. So it will be negative 1 minus 0. The answer is negative 1. So have you seen this remainder, same remainder, R1, can still enter into the remainder we found here, which is negative 1 over 2x minus 1. So we can call it this one as remainder 2. So what we're going to do here is we use the same procedure. We say negative 1 over 2x, divide it by negative 2. So the answer will be negative, it will be positive 1 over 4. So you multiply 1 over 4 times negative 2x. The answer will give us, we have negative 1x over 2. Then negative 1, positive 1 over 4 times negative 1. The answer will be negative 1 over 4. Then you do the subtraction there, we will have negative 1 over 2x minus negative 1 over 2x. So negative times negative, it will be positive. So we have negative 1 over 2x plus negative 1 over 2x. That is same as 0. And we have negative 1 minus negative 1 over 4. That one will give us negative 3 over 4. That is our remainder 2. In fact, that was supposed to be remainder 3, not remainder 2. Our remainder 2 was negative 1 over 2x minus 1. That's all.
Thank you very much, Jabez. Yeah, so what he has explained is exactly what we are supposed to do. So thank you for that, what you've said. Why we name these as the main remainders is because this is where this could not go into this. So that's why we name these. The remainders in between, why we don't name them most of the time is because most of the times why we don't name them, because we don't have to have we don't want to have a lot of remainders, but not to confuse yourself. Every remainder that you have, you can be putting the number on it, and then you get the remainder. So here, if we're at 0 here, if here we're at 0, most of you are getting this to be your remainder. You don't get this side, you get this side. And when you're getting this side, the remainders, if here were at 0, your remainder would have been this, not this on top, or the one we named. Most of you are getting the one we named R1. You don't get this. You get the one just before you found 0. And before you found 0 here, your remainder was this. So this will be your PGCD, and you make it what? You make it unitar if it's not unitar. That's all. So, but here on our answer here, we found a constant. So we just get the same constant to make it unitar, and our PGCD is this. We don't go back to this, whatever. We only go back to this when we found this 0, because we can't get 0 to be our PGCD. That's why we get the remainder before found 0. But when we find a constant, this is what you get to be your PGCD. Are we okay? Those who had problems with getting the PGCD, I hope this must be cancelled. You don't get here. Are we okay? Hello?
Yes, it's okay.
It's okay, right?
Yes.
Of course, I just want to get clarity.
Yes, yes.
Like every time we have a constant, then our PGCD is 1?
Yes.
Oh, okay.
Why is it 1? You don't ask why it will be 1. Why
is it
why
1?
we would, it's because it's unitar. PGCD must be unitar. So the constant which you found, for you to make it unitar, it means it needs to have a coefficient of 1. So for you to make it to have a coefficient of 1, you just multiply it by its inverse. Are we okay?
Yeah. Okay, I get it now.
Okay. No mistakes, guys. No mistakes. Okay. We can move on. We go to our, so here, now this is where B, we need to apply theorem de Bézout. We learned about this, and I said in the TDs, you understand it more how we use it. What is your U and what is your V? So our question says, déterminez U et V tel que A AU plus BV égale 1. This is the equation, l'équation de Bizot, theorem de Bizot is this. So we are going to determine our U and V. So we come here. So that's why the PGCD is very important, because you finding this, the PGCD, naming these in a right order is very important, because you use these equations here to come up with your U and your V. That's why I was avoiding to write a lot of reminders. I just write the important ones, the ones which are more important when I'm doing my division Euclidean, when I'm finding my PGCD. So we go B is equals to B. So first of all, on a B equal, it's R which is going to be, right? So our equation, we write it in this form. Our B will be equals to R for B, QR plus R. We're going to our equation here. When we did our division Euclidean, it ended up to here, right? So our remainder was R1, our Q was X, this was our Q, and our R was going into B. So the equation which we're going to have is B is equals to R for Q1 plus R1. Then we want to to make R1 the subject of the formula. So this goes the other side, right? So we're going to have donc R1 is equals to B minus RQ1, where Q1 is equals to X. Our Q1 is equals to X here. So we come and replace here. So R1 is equals to B minus RX. R1 is equals to B minus RX. This one. I sent the question in the group. The one who's asking a question, please. I don't know what he means, a question, please. I sent it in the group, so I'm sure you have it. You can check on exercise 2, B. On R1, why is 2 negative instead of positive? You mean here, negative 3x, this plus this to be x. Negative 3x plus x is equals to what? Negative 2x. The one who's asking the question, are we okay there? Okay, that's why I said be careful with the signs. The minus signs, how they change. When you're solving this, relax. Be calm, because when you miss it out here, because these questions, they're interlinked. So when you miss it out there, everything will be wrong down. So okay, so we continue. We continue. We continue on a B equal R for QR plus R1. Then we made R1, the subject of the formula was this, and our Q1 is equals to X. We come and replace it. R1 is equals to B minus RX. And then on the other side, on our OC, the other side here, our Q, we've got the Q and our R2. And what this dividing this. So we come up with the equation. What will be our equation here? Our equation to be R is equals to R1 Q2 plus R2, because we know that it's R1 which was dividing R. So this will be our equation. It's equals to this. And then we already have, that's why here we made the R1 the subject of the formula, so that in this formula we come and replace it. So our R1 is equals to B minus RQ1. So we'll come and replace here. So we'll come and our Rx, right? So we'll come and replace here R is equals to B minus Rx Q2 plus R2. This is normal mathematics. And then donk R is equals to, we distributed, we're going to have BQ squared minus RX RQ, or BQ2 minus RXQ2 plus R2. So our main aim is to make it, our main aim is to make it in the equation the Bézout. And the Bézout is RU plus BV is equals to 1. This is what we're coming up with here. So we put like terms together. So we know that this our R2, we make R2 the subject of the formula. So all these, they go the other side, right? We're going to have R plus RXQ2 minus BQ2. You factorize the R, we're going to have R plus XQ2 minus BQ2. This is our R2 here. Then the value of R2, we already found it on top here. It was what? R2 was equals to this. Our R2 was equals to that, right? Here. Yeah. So here, yeah. So we continue here, right? So we have this here. We've done this. Like terms together, we've put to have this plus XQ2 minus BQ2. We put the values of Q2. We put them and the values of Q2. It will be negative 1 over X, negative 1 over 2X plus 1 over 2 minus B is equals to negative 1 over 2X plus 1 over 4. R2. Conseke RU plus BV is equals to 1. So we already have the R, we already have the what? The B. So we have to make these two in a form of 1. And for us to make this in a form of 1, we know that to be negative 3 over 4. That's our R2. So for us to make it 1, we need to multiply by negative 4 over 3. So we multiply negative 4 over 3 everywhere, even this side we multiply it. So that we'll put it in form of 1. So this will be 1 here, right? Then we've got R for R plus X. What your Q2, the one you found on top, your Q2 here, times the negative 4 over 3. What we've multiplied here. And then plus B, here why it's plus here, because the negative on the 4 over 3, you've distributed.
Hello.
So yes.
Sorry to take you back, but people want you to start over from B because the network was so bad they couldn't get what you said.
Okay. Okay, so we'll start again. We'll start again. Yeah, so we'll start again. So we've got honor B is equals to, first of all, I said they want us to find our U and our V using this, our R and B. So we have two equations. We've got our equation of R1, Q1, R, B, and R. And we've got our equation of R1, R, Q2, and R2. So the first equation which we have is honor B because it was R which was going to be. So on R base is equals to R for Q1 plus R1. Donc R1 is equals to B moins R Q1. Q1 is equals to X. Q1 is equals to X. We found our Q1 to be equals to X here. So here we made R1 the subject of the formula. So it will be B minus RQ1. We come and replace here the value of Q1 was equals to X. We come and replace it. Our R1 is equals to B minus RX. That's what I'm doing. I'm repeating on part B. Yeah. So we have this equation. B is equals to R for Q1 plus R1. Where are we getting it from? Our main aim is to find U and V. Where are we getting it from? That's why you finding the PGCD was very important, because we need to use these values here, the R1, the R1, the R2, the Q2, the Q1. So we're going to come up with, we have two equations. Theorem de Bézout, we've got two equations. So the first equation is B is equals to R for Q1 plus R1. This equation, you did it in your Q. You know this equation. When you do division Euclidean, you write it in this form. You write this, the one which is being divided is equals to, this is being divided is equals to R for Q1 plus R1, which is the remainder which you found with your quotient, and this R which is dividing this. This is a normal equation, so no one should get confused. I'm sure everyone has studied the notes and you've watched the quiz if you never attended the actual lesson. So this is the normal equation. When you do division Euclidean, for you to find B, you can just multiply R for Q1 plus R1. You're going to find your B. So we write this equation in terms of the one which is being divided is equals to the one which is divided times the remainder plus R1. We make R1 the subject of the formula. This goes the other side. So we're going to have R1 is equals to what? B minus RQ1. B minus RQ1. Q1 is equals to X. Q1, we found that it was X. Our Q1 was equals to X. We come and replace it. We come and replace it. R1 is equals to B minus RX. And then on our OC, the second equation was the division of this into this. So to be written what? This one which is being divided, which is R, it will be, so it will be R is equals to R1 for Q2 plus what? R2, just the same way you wrote this, plus R2. Then we found the value of R1. That's why here we found the value of R1. So to come and replace it here. We replace it here. What are we going to have? R is equals to B minus RX Q2 plus R2. Donc R is equals to, we distribute. So this it will be B Q2 minus RX Q2 plus R2. Plus R2, which is this. We make our R2 the subject of the formula. Again, since we've come up with this, R2 the subject of the formula. So all these will go the other side. So what R2 is equals to R plus, this will be plus here, plus RX Q2, this will be negative, negative B Q2. R2 is equals to R. We factorize the R plus X Q2 is equals to minus B Q2. We put the value of Q2 and Q2. We found its value. The value of Q2 is equals to this. We come and put it here and here. What are we going to have? We have our R, which is outside. R plus X, this is R plus X. We put our Q2, which is negative 1 over 2X plus 1 over 4, minus B is equals to 1, negative 1 over 2X plus 1 over 4. So we've already found our R. We are expressing this equation in form of the theorem de Bézout, which is RU plus BV is equals to 1. So, so we have this. So we have this and this. On sec RU plus BV is equals to 1. So we already have the R, we already have the B. So automatically these will be our U and these will be our V. But we cannot conclude that this is our U and this is our V when our R2 is not equals to 1. So we're going to express our R2 in form of 1. And we know that our R2 was -3/4. So what are we going to do? For us to make it unitary, to make it 1, here we have to multiply the inverse of it. So to be -4/3, then you multiply, you know what you do on the left, you have to do it on the right. So you multiply the -4/3 everywhere this side. So on this part, it will be -4/3, you multiply it here. Here it has a negative, the negative here it will come where there was a negative for B, so you have a plus. B is equals to -x/2 plus 1/4, 4 times 4/3. This. So now you've expressed it in form of RU plus BV, which is equals to 1. Here you have 1, so you've got R for this whole thing plus B for this whole thing, which is equals to what? To 1. So they said find U and V. Our U is everything here, and our V is everything here. Alors, donc, U is equals to R plus X, -1/2x plus 1/4 times -4/3. This is our U. This is our U, our R, so this is our U. Our V is everything here. I just distributed the 4/3 this side. So it gave me -4x/6 plus 4/12, which will be just be 4/12 minus 4x/6. That's it. So we have determined our U and our V. Are there any questions?
Yes, I have one.
I can't get you. I can't get you. I can't get you. Be loud.
I have one question.
Yes, you can ask.
On the remainder, remainder 2.
Yeah.
Why did you just put a 1? Because even if you multiply the -3/4, as in if you multiply the inverse of it, still it's going to give us 1. So I just put a 1.
Why we didn't put 1?
Yes, that's a question.
What is our R2? What's the value of R2?
The inbox.
That was R2 was
the kinds of pictures.
-3/.
Your friends, they are making noise there.
Why am I gonna hit me up with the
Your friends are making noise.
That is not my team.
Copy code.
Hey, whose mic is on? Okay, we can. You can continue. Yeah. So
I was asking that, since we already found that, okay, as in the remainder 2, we're going to, as in, why didn't you just replace it by, okay, so let me ask you. So if we had the remainder, which was unitary, without it being a constant, would have just placed the same equation that is unitary without us multiplying by the inverse.
If we found what?
You found an equation that was already unitary, that was already unitary.
You leave it the way it is.
We won't multiply it by the inverse.
No, it's unitary. Now you are talking about the PGCD, but when you are talking about you finding U and V, you have to divide it by its inverse, because that other side, it must be expressed in the equation de Bézout, which says A fois U plus B fois V égale A. For you to determine U and V, you have to prove the equation. If your equation A fois U plus B fois V is not equals to 1, then you can't say that those multiplying R there is U, and the one multiplying B is V, because it does not agree with the equation. And you saying, why didn't we just put 1 here? R2 is not equals to 1, PGCD is equals to 1. PGCD and R2, they are two different things. R2 is the remainder which you found there, but for PGCD, for us to find PGCD, we have a rule saying PGCD is unitaire. So we made the R2 to be unitaire by what? By multiplying it with its inverse. That's it. That's why we do not put 1. Are we clear there?
Yes, I'm clear.
Thank you very much. Any other questions? Any other questions on this question?
There's a question.
Yes, who is talking?
It's David. Just put down a
Yes, yes.
Screw up. I mean a bit.
Yes, yes.
Yeah, like where did you get the equation which says that R1 is equals to B minus AX? Like where did it come from?
Where did R1, I have a question for you. Where did R1 minus B, R1 is equals to B minus RQ1 come from? Before I give you the answer, where did it come from?
Isn't it the question?
Yeah?
The question they have given us before.
They have given us the equation in the question.
I'm not sure.
Anyone to answer us, why is our equation B is equals to alpha Q1 plus 1? Because if you do not understand this equation, you cannot understand everything down here. Anyone who has understood? Anyone?
I can give it a try.
Yes, go ahead. Your name?
Yeah.
Your name?
Squared. Oh,
Your
Ted.
name?
Ted.
Eh? Okay.
Teddy. Yeah.
Okay.
So the thing how we are coming up about with the equation, for example, B, for it means for us to have this equation A by Q. So I think you from after we divide this, it's more like you're reversing it to find B. So for you to find B, you have to multiply A times Q1 plus R1, which is the remainder.
Are we okay? David.
Sorry, I didn't get what he said. They had some network problem.
This equation is in the core. It's when we are studying divisio Euclidean, we said if this is dividing this, and we found our remainder to be this and our quotient to be this, the equation which we're going to have is B is equals to alpha Q1 plus R1. This means that this R is dividing B, and the remainder which we're going to find is Q1. The quotient is be Q1 and the remainder to be 1. Keep it per care. This is the equation. It's the same equation we have used here. Now we're dividing this into this. So this is the one which is divided. So it will be R is equals to R1 for Q2 plus R2. This is the equation which we have here. Where is this equation? R1 is equals to B minus Rx. What is our value of Q1? Q1 is equals to X. So in this equation, we made R1 the subject of the formula. After we made R1 the subject of the formula, it gave us B is equals to R for Q1. And we said Q1 is equals to X. Q1 is equals to X. So we come and replace where there's Q1 with our X. That's why R1 is equals to B minus R for R for X. Are we okay, David?
Yeah, we're okay.
Okay. Any more questions before we move to the other part? Any more questions on B? If we're all okay, we can raise our hands. If we're all okay, okay. This is normal mathematics, knowing the equations, the importance of making your work very clear. It's very important. That's why there's one who was solving this same question. I noticed he never used this table. It will be very hard for you to identify which one is your R1, which one is your Q1. So always you get used to this, and this is the easier way for you to identify your R2, your R1, your Q1, your Q2, and it's very easy for someone to follow. So use this method, please, and make your work as clean as possible and as simple as it's supposed to be. It's not complicated. So.
Oh, sorry,
Yeah.
I've got a question.
Yes.
Yeah, I think I didn't get clearly on what if the R2 it's 0. What do we do here where it says R2 is equals to this equation? Since in this case, in this case where we have negative 3/4, we are multiplying it by the inverse. Now, what if it is 0?
When it's 0, which means which one will be your remainder?
It will be the equation before we found the 0.
So you use that,
one on top.
and then you make, yeah. So you are going to you are going to use that same equation to be your R2. Okay. 0 is nothing. 0 is nothing. So that's why when we find our remainder to be 0, we don't get 0 to be our PGCD because 0 is nothing. We get the remainder before we found 0. So here, if we found here to be 0, what will be our R2? Our R2 will be this. Because this is where we're going to get our PGCD from. If it's already unitary, you're just going to put it here to be a PGCD. And when it comes to the R2 and you come and put it in terms of R2, you're going to get this same one. And then you're going to, for it to qualify with the theorem de Bézout, you're going to make it 1. For you to make it 1, because the equation tells you is R for U plus B for V is equals to 1. So for you to make it 1, we are going to divide it with the inverse of it so that you cancel it. And then you're going to divide the other side again with the same thing. And then you're going to name your U and your V.
All right, thank you.
You've understood?
Yes.
That was a very good question. Any other questions? Okay. We're moving together. So we go to C. We go to C. C says, montrer que U est verso unique si on suppose que degré de U is less than degré de B, degré de V is less than degré de A. So they want us to show you, to montrer que U est so unique if we have these propositions. Degree de U is less than degree de B, and degree de V is less than degree de A. So this is what we're going to show, montrer, we have to show. So first of all, on suppose qu'il existe U, so we're going to name UA, VA, tel que RUR plus BVR is equals to 1. You know this equation, we just put U as these, we've named them U1 and U what? A degree the U1 is less than degree the B. A degree the V1 is less than degree the R. We're supposing here on suppose it exists U1, so we have U1 and V1 take R for U1 plus B for V1 is equals to 1. A degree the U1 is less than degree the B. A degree the V1 is less than degree the R. Donc, we're going to equate the first to the second, right? The normal equation, which is RU plus BV is equals to RV1 plus BV1, because we know that our 1 here is equals to this. So here, if we say RU plus BV is equals to 1, instead of us putting 1, we put in its equality, which is RU plus BVR. Like terms together, we're going to have RU minus RU1 is equals to BV1 minus BV. Then R is equals to U minus U1. We factorize the R is equals to B. We factorize the B, V1 minus V. So here, this is the equation which we have. We know that if we have an equation in this form, we have this equation here. So what we're going to say in our proposition of theorem de Bézout, says on A et B, so premier entre A. A and B, they are premier entre A. It means that A can only go in itself, and 1 can go into it, and B can go in, it's only B which can go into itself, and 1 can go into B. So it means B cannot divide the A cannot divide what? B. And when we're in this form here, this form tells us if we've got this is equals to this, it implies B is dividing this whole thing here. But you know that B cannot divide A because A and B are premier entre A. So the proposition which we're going to get is B can divide U minus U1. So on A et B so premier entre A. Donc B does not divise A because they are premier entre A. So in this equation, we know that this means that B is dividing this whole thing here. But when B is dividing this whole thing, it will not divide A because A and B are premier entre A. So B only divide U minus U1. So donc we have B divise U minus U1. Donc it exists. If we divide our B into U1 minus, we're going to have what? Q appartient à A tel que U minus, so U1, U minus U1 is being divided. So we say the one which is being divided is equated to this, the one which is dividing it for Q. So we're going to have U minus U1 is equals to B for Q. Our remainder is equals to 0. So degree the Q, this our Q, its degree, it will be greater or equal to 1. So it will start from its degree being greater or equal to 1. Degree the U minus U1 is greater than, if this is dividing this, it means the degree of this is greater than the degree of B. So here we're saying degree the U minus U1 is greater than the degree the B, which is true. If this is dividing this, it means this degree is less than the degree of this. And then if this is greater than this, then what are we going to have? What do we have? We have degree the U minus U1 is less or equal to sub the degree the U, the degree the U1, which is less than the degree the B. So we're saying in the normal case, U minus U1, its degree must be less than the degree the B. According to what we said degree the U1 is less than the degree the what? The B. But here we've got U minus U1 is greater than degree the B. Alors on a une contradiction. Donc, if we have a contradiction, it means donc l'unicité de U et V. Alors U et V est unique because of the contradiction which we have here. So U and V are unique, and they said we should show that these two, they are unique, and we have shown that they are unique because when we did this assumption, it gave us a wrong assumption of saying the degree of u minus u1 will be greater than the degree of b, which is is opposing what we have here. Alors, on a une contradiction. Donc, l'unicité de u est vraie. That's all about question C. Any question? Any question?
I would ask if you can go through it once more.
Has anyone understood? Those who've understood, you can raise your hands. Those who have understood, you can just raise your hands. Those who've understood, you can raise your hands. It's not that you explain. If you've understood, just raise your hand. No one has understood. Where is the question? Where is the problem?
As for me, I think I didn't understand exactly what the question is asking us.
Okay, the other ones, before I pass through it so that I know where to put emphasis on. Others, where is the problem?
Okay, we have forgotten the question and you need to go through again.
Do you have the question?
Can you please start from part B?
From where?
Part B, where we have the, where is it? Where the B is equals to F1Q plus R1.
We're on question C. You've not understood B. Hello? Hello? Where is it? How many have not understood B? Those who have not understood B can raise your hands. Those who have not understood C should raise their hands. C. C is like it's everyone. I gave you those questions so that you can be checking while we're doing them. Okay. Okay. The one who asked the girl, where did you say B I should start from? Where didn't you understand? The one who said B, where?
From the beginning.
From the beginning. Okay. Can anyone who's understood B to explain it to us? Anyone? There are some who agreed, who said they understood. Anyone who understood B? To explain it. Anyone who has understood B?
Okay, I think I have something to say, not really explaining, but just to...
Okay.
For someone to understand how they are generating those equations, I think it's important to understand division de Clodienne, because there is the same pattern they follow. So minus knowing that, I think the person is going to be lost here. So she can just check the division Euclidean, then it's going to be fine.
You've understood.
Yeah, I did, but maybe explaining could be difficult.
Because if okay, that's good. Okay, I get. Okay, so I said this is in the coup. This is in the coup. This equation is in the coup. On B, we want to determine our U and our V. Knowing that our equation for U, where we find our U and V is IU plus BV is equals to 1. That's what we are verifying. And for us to verify this, we have to use the division Euclidean, which we have done. So what are we going to do now? So we said, please follow me. Studying the coup is very important. We've uploaded those videos on the YouTube. You guys are supposed to pass through them. Why you've not understood? Some things can only stick when you continuous repetition on them. They understand the coups. Study your coups. Know the equations. I've been telling you, know them by care. Don't just memorize them. Know how they are developed. What are we saying? We said on division Euclidean, the first equation which we're going to have, we're having R is dividing B. R is dividing B, Q1 is our quotient, R1 is our remainder. So our equation, what we have, our equation according to the equation division Euclidean, when your remainder, the degree of a remainder is less than the degree of the one dividing the degree of R. Our equation which we're going to have B is equals to what? To R for Q1 plus R1, which is our remainder here. This is a fixed equation. It's the same equation which we are going to have here. Our last remainder is this. When we reach this point, this could not divide here because the power, this is greater than this power here. So what would be our equation here under division Euclidean? This is dividing this. So our equation will be R is equals to what? R is equals to R1 for Q2 plus R2. It's the same thing which you've gotten here, the same criteria, the same method you've used to make this equation. It's the same method you're going to use to make this equation. So what is next now when we do this? What is next is, let us, because we've come up with these two equations, and in the other equation we've got R1, but from the first equation we can find the value of R1. So we make R1 the subject of the formula. How do we make R1 the subject of the formula? We introduce on both sides an inverse of this. So here we're going to have negative R for Q1. Here we're going to have negative R for Q1. It will cancel with this, it will cancel with this. We're going to have R1 is equals to B moins R for Q1. What is the value of our Q1? Q1 is equals to our Q1 here, our quotient, we found that it was X. So what are we going to do? Q1 is equals to X. We'll come and replace it in our equation. R1 is equals to B minus RX. Are we okay?
Yeah.
The mic, are you getting me?
Yes, boss. I have a question.
Where?
What is the purpose of making R1 the subject of the formula?
What's the purpose of making R1 the subject of the formula? Is because we have two equations. We've got this equation here and this equation here. And in the other equation, we've got R1. So from the first equation, we can find the value of R1 so that when we make the value of R1, we come and put it in this so that we have one equation. Our main aim is to have one equation which at the end will be generated to be R for U plus B for V is equals to what? To 1. That's our main aim. And our RB, this is division Euclidean total. This is division the each division Euclidean total is this, the total. So you need to come up with one equation of this whole thing. So we've got two equations. When you've got two equations, we've got this equation here and this equation here. And the funny thing is that in this other equation, you've got your R1. So if you've got your R1 in this equation, you can make R1 the subject of the formula from the first equation which you've come up with. And your first equation is B is equals to R for Q1 plus R. And R1 is equals to B minus R Q1. Q1 is equals to X, which is this. Hello, R1 will be equals to B minus RX. We found what our R1 is. From there, are we okay there? Is everyone okay there? If we're okay, we can raise our hands. Are we okay there? I expect everyone to raise their hands because we don't want to come back to this. That's why when we say, have you all understood? Don't let me go to another part when you've not understood. You'll be more confused. So if you've not understood, point out they have not understood. Why is this and this? And then I'll explain according to my capacity. Okay, so we are all cool there, yes?
I haven't gotten it properly. The equation.
Be loud enough.
I haven't gotten it properly. Like
how?
A multiplied by Q1 plus R1.
Your network is very bad, so I'm failing to get you the last part. So what? Hello? Right.
Hello. Okay.
You're right.
Let me use another phone.
Switch off your mic.
The first part, which says B is equals to A multiplied by Q1 plus R1. Kindly explain again. I didn't get it properly.
Now, you've gotten this other one.
Yeah, the other one I've gotten it.
Then you need to also understand the first one. Because the same, how you found this equation is the same way you found this equation. Here we've got R is dividing B. And our remainders is R1 and Q1. You can switch off your mic. We've got Q1, our quotient, this will be our remainder, R1. What are we going to have now? Our equation is, if this is dividing this, then our B will be equals to what? B will be equals to R for Q1 plus R1. The second question, we've got R1 here is dividing R. So if this is being divided by this, the value of R will be equals to what? R1 for Q2, because it was a remainder here. For Q2 plus R2, it was your remainder here. This is how, the way you've come up with this equation is the way you come up with this equation. That's why I said, understand the criteria of how we come up with this equation. This equation is in the KU. In the KU where we did the division Euclidean, it's there. It said when the degree of the remainder is less than the degree of R here, then you are going to have an equation of B is equals to R for Q1 plus R1. That's the equation. Some of you, when you are solving the first question, after you found your R1 and after you found your Q and your R, you are putting it in the equation. It's that same equation that you are making here. It's just that you are putting the letters R1, Q1 there. You just had one remainder and one quotient. Here you've got this. That's why I'm naming them one, and you've got another one. That's why I named them Q2 and the R2 here. Are we okay?
Yes, we're okay.
So we move on. So honor, OC, R, we've seen how we've come up with R. is equals to this. We come and replace the R1. That was the main essence why we made the R1 the subject of a formula. We come and replace it here. When we replace it here, we're going to have what? B minus Rx, which is this, for Q2 plus R2. Donc, R, you distribute this times this times this. You're going to have R is equals to BQ2 minus Rx Q2 plus R2. R2 is equals to R plus Rx Q2 minus B Q2. We've made R2 the subject of the formula. So all these, they've gone the other side. So we have, we factorize the R. We factorize the R, we're going to have R here plus X here, Q2 minus BQ2. Replace the value of Q2. What was the value of Q2? It was our Q2 was negative 1 over 2x plus 1 over 4. We come and replace it here. We're going to have negative 1 over 2x plus 1 over 4 minus B, negative 1 over 2x plus 1 over 4. This is our Q2, this is our Q2. We have our R and our what? And our B. And we know our equation is R for U, B for V is equals to 1. So we need to make R2 to be equals to 1. And since we already have our what? We already have this, and here we need to make it positive. It needs to be plus. So how are we going to make it positive? You see that this goes, you multiply it inside D, all that. So how are we going to make it positive? And how our main aim is just to make this one here. So this, we know that this value was negative 3 over 4. So I'm going to multiply it with an inverse of it to make it 1. So to make it 1, so that we understand this theorem, so that we prove this theorem, because our main goal is to go to this theorem so that we find our U and our, because when here we make 1, and then we've got our B and our R, which means we're just going to get what is multiplying R to be our U and what is multiplying B to be our V. So here when we multiply, we're going to have 1. Then this will be multiplied throughout. What you do on the left is what you do on the right. So you multiply it everywhere. What are we going to have? We're going to have negative 4 over 3. Here we're going to have 4 over 3. The negative will multiply with here to be plus. So we've now expressed this formula. We've got R for this whole thing will be our U, plus B for this whole thing will be our what? Our V is equals to what? To 1. And the question is saying determine U and V. Allow your U is equals to all this equation and your V to be all this equation. Here you just distributed it. That's why your V at the end was equals to this. Any questions? Any questions? Have we all understood?
Yes, it's understood. But can you simplify it any further, or just
No.
leave it?
If you want, you can, but we'll just be wasting time. Just leave it the way it is. Those which you can simplify, you simplify them. Like this one, which you did here, it was very easy to simplify it. Yeah, that's how we simplified it. This one, you multiply this, and then you multiply. If you want, you can do it. But when you just write it like this, it's just correct. Your main name, they just want you to apply theorem de Bézout.
All right.
Yeah. Any other question? Understand the theorems. Know the equations of the theorems by heart. Okay. If we're all okay, we can raise our hands. On this part, we close the chapter on B. We're not coming back. Unless in the inbox, we'll come back, those who've not understood. But there are some of your friends who've understood. Ask your friends. Maybe they can explain better than me. The girl had asked the question, is it okay?
Yes, it's okay.
Okay.
Boss.
Yes.
Ako ka positive B kachisa shani.
Ka positive B. Where is here we're multiplying with 4 over 3. We multiplied with negative 4 over 3 everywhere. Here we multiplied negative 4 over 3. We just put it in my brackets. Here we multiplied with negative 4 over 3, but we removed the negative and took it outside. We multiplied the negative outside to give us this positive. Now mfwika.
Oui.
Sir.
Yes, Moses.
When finding the value for V, in this Chilong equation, A dot something at the end there, plus B, open bracket, negative X over 2 plus 1 over 4. You have written 4 over 3. Was it not supposed to be negative 4 over 3?
It was supposed to be negative 4 over 3, but it's one and the same thing. The negative has gone outside. Here, in the beginning, you had a negative here. So when you multiply the negative 4 over 3, you are removing the negative to take it outside, which will come and cancel this. So that's why you have a plus here. Because it's supposed to be in this form with a plus here. So you see that this negative, which is here, distribute it inside with everything. And then you distribute it inside to cancel this, even this. Or you take the negative which you found here, just take it outside.
Oh.
You get it?
Yes.
Are we fine? Everyone is just okay. Before we move, ask questions. Are we okay? Okay. We close the chapter on B. Okay, there's a question. Finding the remainder part. The remainder will be found when the degree of the divisor can no longer enter into the divided, not just after finding the difference. The remainder will always be found after finding the difference. But the final remainder of the whole division will be the one which will be when the divisor can no longer go into the divided one. That's your final remainder of that division Euclidean, and that's a notable one. But every time you do the difference, you find the remainder. Are we okay, Jabess? Jabess? Okay. Any other questions, guys? Any other questions on this? Okay, we move on. So we go to see. Montrer que U est V so unique. Show that U and V, they are unique. So for them to be unique, it means that the other way is not true. The other way of saying degree de U is greater than degree de B. It's not true. So you are showing that it's unique. You have to show that it's unique. It's only true in one way. It can't be the other way. That's what you are doing when you say montrer que U est V so unique. Si on suppose que if we, and they've given you a condition, they are unique if you pose that this degree de U is less than degree de B and degree de V is less than degree de A. So what are we going to do? So we come here. We say, okay, if it's like that in our question, if it's like that, what are we going to do? If it's like that, then on suppose it exists. So we suppose that it could be U1 and V1 take IU1 plus BV1 is equals to 1. A degree de U1 is less than degree de B, and degree the V1 is less than degree the R. We've paused what we have in the what? But we've named this U1 and the V1. So we have this first part and we've paused another part. This first part is represented in the equation RU plus BV is equals to 1. This whole thing. So we go now, we've supposed this and is equals to 1. So we come down, we equate now the what? We equate the 2. We know that URU plus BV is equals to 1. And the RU1 plus BV1 is also equals to 1. So it means where there's 1, you can put what? You can equate it to what? To RU1 plus BV1 is equals to 1. That's what we came to do here. Where there's 1 here, we replace it with RU1 plus BV1. We'll put like terms together. This goes the other side, the other on the other side. What are we going to have? We have I is equals to U minus U1 is equals to B is equals to B V1 minus V1 minus V. On A and B, so this go and start the theorem de Bézold because we have this, we have these notes, and it says on A, when you have this on A and B, so premier entre A and B, they are premier between the two. It means that only A can go in itself and only B can go into itself. A cannot divide B and B cannot divide the A. That's what it means. So if it's like that, then if this cannot divide this, because when you write it in this form, it means this is dividing this. So if this can, we know that this thing is dividing this whole thing, but you know that this cannot divide this because they're premier. So B will only divide U minus U1. Alors, we come up with on A et B. We said they are premier entre them. Donc, on va avoir B divise U moins U1. Donc, so what we're going to have there, if this cannot divide this, it means this can divide what? This, and this can divide this. Only this can divide this. This cannot divide this. This B cannot divide A because the premier entre there, and we're interested in these two. So this can divide this. So alors B divise U moins A, donc il existe Q appartient à A. So if B can divide this, then we know that there's a quotient. When they are dividing, we're going to find the quotient. That's why we say it exists Q, which is the quotient. And the equation, when you do division Euclidean, the equation which you're going to have is this, and your remainder is equals to 0, and your remainder is equals to 0. Here you're not finding the PGCD, you're just doing the division Euclidean, and your remainder is equals to 0, and you have your Q. So we know that when you do our division Euclidean, if this is dividing this, our equation which we're going to have is U with the one which is divided minus U1 is equals to B for Q. And we know that the degree of Q is greater or equal to 1. The degree of Q will be greater or equals to 1. Alors degree de U, if this is dividing this, what does it mean? It means what? It means the degree de B is less than the degree de U, because only the one with a lesser degree can divide this. So what are we going to have? Degree de U minus 1 is greater than degree de B, which is in contradiction with this, because you know that degree de U is less than degree de B. And here we're saying degree de U minus degree de 1 is greater than, because here again they are subtracting each other. And you know that if they're subtracting each other, the degree on top will not change. So still more, it's the same thing saying the degree here must be less than the degree here. But according to this equation, it's telling us that degree de U minus 1 is greater than degree de B. Although on a degree de U minus U1 is less or equal, we're quoting this now. Is less or equal, soup, if we separate them, degree de U, a degree de U1, a less than degree de B. We're quoting this one, and we know that this why we equal is greater or equal. This is just the same. We can write it in this form. And in our equation, you know that this is less than this. Then we've got a contradiction with the proposition which were given to show that it's unique. Alors, having this proposition, we have shown that U et V est unique, donc l'unicité de U est V. And it will only be true when degree de U1 is less than degree de B. That's all about this. Any questions?
Kindly repeat the last part while it's saying that the degree the U minus U1 is less than or equal to the other one.
What's inside here is U. What's inside is a degree of U1 and a degree of U. This is less or equal. The degree of U is the same degree here. It's equal to this degree here. This degree, so that's why they said it's less or equal. When you subtract these two, the degrees on top will not change. Rules the indices, the degree will just be the same. That's why they're saying it's less or equal. The degree, the U and the degree is just, they just put it here to equate that even when you just put them in them being lonely, this on its own, this on its own, the way it's been indicated in the diagram, it will still give us, it will still be less than degree de B. Even when you subtract them, it will still be less than degree de B, but the equation is telling us that it's greater than degree de B. Alors, on a une contradiction. Donc, l'unicité de U est V. Are we clear there?
I'm not satisfied.
How? Where is the problem?
Why is it saying that it is less than when it is not going to change?
What?
The degree of U1, degree of U1. It's not going to change, but why is it saying that it can be less than?
That it can be less than or
Can be less than the other one.
it can be less than or equal.
Yeah.
That's a normal way of writing it. That's a normal way of, because when you just say equal, it will not be that much strong, but the best way to write is less or equal. It can't be greater or equal, it's supposed to be less or equal. It can't be greater or equal. And why we're putting equal? Because there's a time when this can be equal to it. And in most cases, it will be equal because this degree here minus the degree here, it will be less or equal to sub degree U. Is here what they're writing sub, they mean the highest degree and the highest degree. You've done this. And why they are putting it in this form, if you wanted to have just written degree de U A is less than degree de B according to this, but we want to separate them so that we show even just the degree de U1 itself is less than B. We just want to come up with this. So this can be represented in this form, and which is just less than degree de B. So this and this, they are less than degree de B. This is what they're telling you, this and this would be less than degree de B. Are we okay?
Yeah, okay. How about there where it's written contradiction? Yeah. What does it mean?
To contradict, they do not agree with the superpose. What you should here you've given a superposition. You suppose that the degree de U is less than the degree de B. But when you come here, it's telling us that the degree de U minus U1 is greater than degree de B. And in this part, we've got U and U1. This is our U1 here. And we've got our U. And in the actual question, it's supposed that this degree is less than degree de B. But here, according to this equation, it's telling us that the degree de B is less than the degree de U minus U1 is greater than the degree de B, which is not in accordance with this. Although we say is contradicting with the proposition. This is the contradiction which we're talking about here. This is contradicting with what we have here. This it must be less or equal to degree B, but it's contradicting with the equation. In the normal sense, U minus U1 must be less to degree B, but in this equation, it's telling us that it's greater. Alors, on a une contradiction. Donc, U est unique. So unique. U est so unique. Are we okay?
Okay.
Any other questions? Has everyone understood this one? We can raise our hands if we have understood. Yes, yes.
Yeah, there's a rule I came across on the degrees. It says the degree of a sum of two polynomials is less than or equal to the degree of one of the polynomials with the biggest degree. Yeah, so looking at that one, where it's saying degree of U minus U1, it's somehow similar to that rule. Now here there's minus. So my question is, does it apply also for minus, the same rule if you know it?
As to apply that what? The degree there?
Degree of sum of two polynomials less than or equal to the degree of the polynomial with the highest degree.
Is less or equal?
Yeah, is less or equal to the degree. Among those two, now the degree with the highest degree is. Yeah, you get that one?
Yeah.
Yeah, so that is for when you are adding. Now here we are subtracting. Can we say this applies, and that's what you've used here?
Yeah, it's the same.
Thank you.
Any other questions?
Let's repeat on the last part, the conclusion part, where you written U and V.
What? Your network, is this David? Your network is cutting. Right. You write in the inbox. Your network is cutting. I'm failing to get you. David, I'm sure it's David. As David is writing, if you've got a question, you can write. Have we all understood? Apart from David, who wants me to explain somewhere, we can raise our hands. Thais, yeah, okay. Who else? Only one person has understood. Okay. Okay. The conclusion of UAB is that here we're showing that UAV is unique. If we're given a condition that the degree the U is less than degree the B and the degree the V is less than degree the R. So what our conclusion is that they told us to show if it's unique. And the only way to be unique, when you find this contradiction here, then it's unique. The proposition will remain the same, that the degree the U will be less than the degree the B and the degree the V will be less than the degree the R. That's the uniqueness which they want you to show there. That's what you've shown here. And you showing it, you've come up with assumptions saying, no, let us suppose we've got another V1 and the U1, which we know that when we multiply them with A and B, they're going to give us 1. And then we equate them now to RU plus BV is equals to RU plus BV1. Then we put like terms together, we come up with the equation and we say D and B are premier entre A. It means B cannot go into R cannot go into B. So in this form, we know that it means B is dividing this whole thing here. And if B is dividing this whole thing and it says B cannot divide R, so B only divides U minus U1. Donc B divides U minus U1, donc il existe Q appartient à Rx tel que U minus U1 is equals to B fois X. You know, when you do the division Euclidean, your remainder here is equals to 0. And B divides this. And if B divides this, and you know that degree the Q to be greater or equal to 1, and if B is dividing this, it means this, the degree here is greater, because if the degree of B was greater than this, B wouldn't have divided this. Although we said degree the U minus U1 is greater than degree the B, this is what we have from this equation. But in our normal assumptions, we say degree the U minus U1, which is just less or equal to the degree of this, which is, that's why we represent it in form of UA degree the U1 is less or equal the criteria or the theorem which your friend gave, which is said is supposed to be less or equal to sup degree the superior one, and here we've got two of them, this and this is less or equal to degree the B, and this here is showing us in our normal equation we have to say this degree is less than B, but according to this equation is telling us that this degree is greater than B, making a contradiction between what we found through the superposition and what is in our question. Although we have a contradiction between this, what we supposed, and what is in the this equation, making U and V to be unique. That's the conclusion. Are we okay? David, is it okay?
I have a question.
Yes.
After that donk AU plus BV, now down there, where you said A open bracket U minus U1 is equal to B open bracket V1 minus V. You said A is divisible by B. How did you know?
It's not divisible by, A is not divisible by B.
Okay.
We said that A and B sont premier entre A. This is a condition d'un theorem de Bizot, that A and B are premier entre the D. When you, this equation here, when you are given this equation is equals to 1, the theorem de Bizot says A and B are premier entre the D. And what does it mean when they are premier entre the D? It means B cannot divide A and A cannot divide B. That's what it means. Only A can divide itself and 1 can divide A. Only B can divide itself and 1 can go into this. So when we come up with this equation here, this is the same equation in a form of what? This is equation in form of a division Euclidean. And this means that this is dividing this whole thing here. But knowing that A and B are premier entre A, it means B is not dividing A. So when you divide B this whole side, B will not divide A, but it will only divide what? It will only divide U minus U1. This is where we say don't B divides U minus U1. And we know that if it's dividing, we're going to have our quotient. And it's going to be written this, if B is dividing U minus U1, this is the equation we're going to have. U minus U1 is equals to B for Q. And then from here, we know that B was dividing this. For B to divide this, it means the degree of this is greater than the degree of B. This is where we say degree the U minus U1 is greater than degree the B, but it's contradicting with the equation because we said U1 is less than degree the B. That's why we said the honor degree the U minus U1 is less or equal to, is just less or equal to a sup of du. So we're separating it so that we put it less to this. Although if this is just less or equal to this, it can be equal to this. And this is less or equal to B. It means our U minus U1 must be less or equal to what? To the degree of B. This is where the contradiction comes about. This is contradicting with this. Although U and V are unique. So unique A, U, V, U and V, so unique. Donc l'unicité de U est V. Are we okay there? The one who asked, is it clear? The one who asked the question, is it clear? Pass through the video, it will be posted
Yes,
on
I'm saying
YouTube.
it's somehow clear up to degree.
Annalise, you did this, the theorem which your friend talked. I don't know if you still talked about it. So you go back to your notes. This is a personal work now. You need to go back to your notes, study those notes for polynomials, understand theorem de Bezout, and come back to this video to be uploaded on YouTube. Come back to this video. I've explained on this point almost 5 times. So you can come back to this, you check it out. You only understand when you continue passing through these things. When you understand the coup, you understand this. If you've never studied the coup, forget you understanding this. Just forget your understanding. So go and study the coup, which I gave you. Pass through the coup, understand it, and come and apply it on this. So that's why I said the theorem de Bezout, you have to study it. Study that theorem. If you've not studied it, you will not understand it. You'll be asking questions. We want to understand the coup here, which is not possible. You can't understand the coup while you're doing questions. You have first to go and study it. So I encourage you guys to go and study, and you pass through, because I have explained this more than 5 times, and it is also in your coup. So we can explain 20 times, but if you've not studied the coup, you will not understand. So go back to the coup, to the notes, study it. If again you fail to understand, go back to this the video which you sent, then pass through it. You have enough time to pass through it. Yeah, and then those who've understood, try to help your friends, please. I'm sure there are those who understood. Try to help your friends. Yeah, you try to help your friends. You guys, you stay in my houses, you stay 5 of you. I'm sure they are still attending Algèbre. For all of you, yeah, all of you are attending. Help one another. Study together, you guys. Study together. You visit each other in the houses. Solve together. Maybe you've understood the other part, the other person has understood the other part. You put your knowledge together, you're going to understand. The girls, you're staying in the cities, you can move there. I'm sure you have got freedom to go into one room to the other. Yeah. Otherwise, today we can call it a session. This is where today we've reached. We've reached on exercise 2. I pray that you understand where you've not understood. My inbox is free. There's someone who asked where are we supposed to send our answers. My inbox is free, and it's free. So if you have any queries, if you have any questions, you can just send in my inbox. And it's strict schoolwork. So if you've got any question concerning school, you can text me and we talk. Yeah, so we've come to the end. It's time up. We started at 15:05. We were supposed to end at 17:05. So we've come to the end of our lesson. Have a blessed day and pass through the work. Bye.